Good morning, Anjali, Brinda, Jairaj Singh.
Good morning, sir.
Okay, have you shared this link with all the students? Because I think Brigu is not joined. Anjali,
Yes, sir.
have you shared this link with all the students?
Yes, sir. Yes, sir.
Fine, fine, great.
Yes, sir.
Okay, so they will join Hope soon. So let's start this session. Hope you all are fine. Now, we have started the data mining functionalities and we have completed that association rules and all those things. Now we are going to see further that which kind of more functionalities are there with data mining. Hope you all can see the screen.
Yes, sir.
So first of all, disclaimer, and then let us start the remaining topics. Yes, we have completed up to this. Now, more functionalities and more kind of patterns that we can mine. So that is classification and prediction. You might have heard about this classification and prediction, but let us have some kind of brief about it. That what is this classification? Classification means you will be having some data, and based on the class, you are going to classify the data. Fine, so what will happen? Okay, let us have some example about the classification and prediction both. So what we are going to do in classification, and this classification we are going to see in detail in practicals. So let us have some brief about this. So for example, you are having one data set in which you are having several attributes and several instances. This is attribute 1, and you are having attribute 2, 2. The last one will be your class that we already seen in Veka. Class can be yes and no. Let us have yes and no as class. Now here you can have n number of instances. Let us say starting from 2, 3, You are having, let us say, around 5,000 instances, and all are having all the values and all are having the classes, right? For example, here you are having yes, then some instance will have no, some instance will have yes. Last one is, let us say, is having yes. Fine. So now what is classification? Classification means in classification, what is your aim? For example, in future, if you are having test data, what is test data? You can consider this as training data. You can consider this the data which in which you are having all the instances, all the attributes, all the values, and with the values are perfect. That you can consider as training data. Now, in future, if some data is coming to you with the same attributes, but you don't have class, that is your test data. So that we are going to see in Veka, how you can perform this. Now, here you don't have Veka. Sorry, we are going to see the Veka later on, but here you are having this test data. For example, you are having all the attribute values. Let us say here you are having your instance number. Then you are having the attribute values, like let us say A2, A3. All the values are there of all the attributes, but you don't have class. For some of the values you are having class, for some of the values you don't have class. What you are going to do in classification, based on this training data, the data in which you are having all the values and all the classes, you are going to prepare kind of model. And based on that model, you are going to predict the class, predict the label. And so here in classification, we can predict the class, that is label. It is kind of nominal value. Whereas in prediction, what will happen? In prediction, instead of having this kind of class, you will be having certain kind of values. Like let us say 5, 6, 9, 8. And with prediction, instead of predicting this kind of class or labels, you are going to predict the values that based on this training data, what value will be there. So here you will be having, you are going to predict numeric value. There is kind of major difference between classification and prediction. Classification, we are having training data, and based on training data, you're going to prepare a model, and that model is going to give us kind of label for data with which or for whom we don't have class. So in short, in classification, we are going to predict the class labels for the instances which don't have class. And in prediction, what we're going to do, we are going to predict the values for such instances for which we don't have values. Right? So in classification, we're going to predict the label or class. In prediction, we're going to predict the value. There is a kind of major difference. And as we have discussed here that in classification, we are going to, based on this kind of training data, we are going to prepare the model. Now, which kind of model can be there? Same way, for prediction also, you will be having some kind of model. Right? So what will be there? Let us see that. So these are the same thing that we have discussed. Now here, as we have discussed earlier, that we are going to have the model based on training data, right? So here, model can be based on classification, if then rules. So this kind of models can be there. If then rules can be there, decision tree can be there, neural network can be there. And here in prediction, we are going to predict the values missing or unavailable numerical data or numeric values. So this kind of model can be there for predicting the class label. For example, if then rule. The A diagram, the A is if then rule. So for example, if person X is having age as youth and income of person X is high, then his or her class for X person will be A. If the age of person X is youth and income is low, then the class for person X is B. So these kind of rules or if then rules can be there. This is the first model. First model is if then rule. If person X age is middle age, then the class will be C. So based on the attribute value, based on the attribute, like here it is age, here it is income, so here it is age only. So based on this attribute values, we are going to predict the class label. And these are the if then rules. In B, you are having decision tree. Fine. So here you are having kind of hierarchy. So first here you are having attribute age, then income. Here you are having directly class. So based on this kind of decision tree, you can also predict the class label. For example, if the person X is having age as middle age or senior, then he or she will be having class C by following this decision tree. If the person's age is youth, then again you need to check other value, that is income, whether it is high or low. If high, then class will be A. If low, then class will be no. Class will be B. Right, so this kind of decision tree can be also there as a model. So that also we are going to see in future with Veka. And this is our neural network. You are having age and income attributes. You are having middle layer, and at the end you can predict the class A, class B, class C based on calculation. And this kind of models can be there. Now let us move further. Okay, in this classification prediction, anybody in doubt? In this classification and prediction, anyone any doubt? Jasim, Brinda. Great. Okay.
No, sir. No, sir.
Great. Thank you, Brinda, for the response. Thank you, Jarat Singh. Thank you, Anjali. Fine. So let's move further. Next point, next kind of pattern, that next kind of functionalities that can be there with data mining is cluster analysis. So here in cluster, what will happen? You're going to create a kind of group of data points, and here with clustering, what will happen? What is the difference between this classification and clustering? In classification, your data will be having class labels. In clustering, you won't be having any kind of label of your data. Fine. So all the data will be unlabeled data without any kind of label, without any kind of class. So how it is possible to create this kind of groups based on similarity of values of instances? Fine. So you are going to find out the similarities between each data points. Based on similarity, you're going to create groups. How to find out similarity? All these things we'll discuss later. That is based on Euclidean distance and all those kind of calculations are there. And based on these calculations, you can say that which data points are having kind of which data points are relevant or closer to each other, you can say, and which data points are near to each other or near to centroids. So based on centroid thing, we are going to find out this similar data points. And based on that similarity, we can create clusters. So while performing clustering, we don't have classes or class labels. Based on similarity, we are going to create this kind of groups. And then later on, after analyzing all this kind of, let us say this is group 1, this is group 2, that is cluster 1, cluster 2, cluster 3. Later on, after identifying all this kind of 3 different groups, you are going to analyze each data points in detail, and then later on you are going to assign the class label to each. Let us say this cluster 1 is having, based on the analysis, you can say that this cluster 1 is having class label A, this is having class label B, this is having class label C. That is the last phase. Initial phase, you will be deciding centroids. Then you will find out Euclidean distance of each data point with centroids. And then whichever data points is nearer, you will assign that data point to that cluster. So let us understand in brief about this, how it is possible. So for example, initially you will be having random data. For example, this kind of random data will be there. These are the different instances considered. And what you're going to do first initially, you are going to identify the centroid for cluster. That is also kind of random thing. You are going to say that I'm going to have, let us say, 3 centroids. The red one, this green one, and let us say this blue one. You are considering this 3 centroids. Now what you're going to do, for example, this is your centroid 1. This is your centroid 2. This is about clustering, where you don't have any kind of class label. And based on similarity, you are going to prepare this kind of groups. Now, how to find out similarity, that is, we're going to discuss now. So this kind of centroid you have identified randomly. And next phase will be, you are going to find out Euclidean distance of each data point with the centroids. For example, this data point. Consider this data point, this one. Let us say this is instance 1. Now what you will do, you will find out distance, Euclidean distance from this data point with C1. Let us say this is your centroid 1. This is your centroid 2. This is your centroid 3. Now what you are going to do, you are going to find out Euclidean distance from this point to each centroid. Now let us say this is distance 1, that is red one. This is distance 3, and this is distance 2. That is Euclidean distance. And so this is, for example, D1. This is D2. This is D3. Here, as you can see that distance 1 is lesser than D2 and D3. So you can say that the data point 1 will be there in cluster 1 because it is nearer to centroid 1. This way you're going to find out Euclidean distance of each data point with each centroid, and this way you can assign the data points in different kind of clusters. Now what is centroid? Centroid is a central point of your cluster. And so this is how you can assign the data points in each cluster. Now, after creating this kind of cluster, what you can say that, let us say, these data points are in cluster 1. These data points are in cluster 2. And these data points are in cluster 3. But later on, after analyzing each cluster in detail, which kind of characteristics are there, which kind of values are there, which kind of similarities are there, you are going to assign the class label. Later on, you can assign. That is the last phase. Right? So, and yes, one more point. What will be your main agenda? What will be your main aim? What will be your main target or goal while performing clustering? Your goal will be to increasing. Let us discuss here. Your main aim, main goal. That is why, while finding out that inter-class similarity and all those things, that is your main goal here. I hope you all can see the screen. Yes. So your main goal, main target, main objective will be, or main principle, you can say. The principle will be maximizing the intra-class similarity. That means all the data points within the same cluster should be having maximum similarity. And minimizing the inter-class similarity. That means the data points from different cluster. Let us say consider 1 point from here, 1 point from here. They will be having minimum similarity. Fine. So all the data points which are having almost same kind of value, same kind of characteristics, behavior, similarity, they will be there within the same cluster. For example, let me give you one small example. For example, if you consider your friend circles in your class, then those friends, or you can say that those friend circles, or let me give an example. For example, this is your this is friend circle 1, in which you are having 10 friends. This is friend circle 2, in which you are having, let us say, 5 friends. Now pick up this friend circle 1. All the friends will be having almost same similarity. Pick up friend circle 2. In that also, friends will be having same similarity. Same kind of likes, same kind of dislikes, same kind of thinking, mindset. Fine. But if you consider one friend from friend circle 2, one friend from friend circle 1, then they both the guys will be having kind of different characteristics, different behavior, different thinking, different mindset. Same way here also, in different cluster, if you consider different data points, then they will be having minimum similarity. But if you consider the same cluster, then they will be having maximum similarity. That is the objective, that is the kind of principle of clustering. That kind of question can be asked. And the principle, the objective of clustering is maximizing the intra-class similarity and minimizing the inter-class similarity. And that is about cluster analysis. Now, other kind of thing with the same clustering, you are seeing this kind of data points which are not there in any of the cluster. What you can consider, or what is the name for this kind of data points which are not included in any cluster? They are outliers. And they are outliers. They have not been considered in any of the
Hello,
cluster.
sir.
They are outliers.
Uh,
For that also, you are having separately two kind of analysis. First is outlier analysis, and second is evolution analysis. Now, sometimes this kind of outliers are also useful. They are having different characteristics, different kind of behavior. For example, if you consider the example of mail, in regular mail, you'll be having normal content. But if your mail is having some kind of promotional words or different kind of words, then they will be filtered as promotional mail. They will be filtered as spam. Right? So normal routine mails or different characteristics
right
are based
now,
on.
sir, you are in that.
Okay, just a minute.
Hello, sir.
Just a minute. Not able to hear. Just a minute. Yes.
Sir,
Yes.
so sir, at which room number are you there? So we came in campus. So sir, can we meet? Like we have to do offline. So sir, we need.
Actually, you are Brigu, right?
No, no, sir. I am Nimit.
Okay,
Actually, I
Nimit.
had logged in from Brinda's mobile. Yes, sir.
Okay, fine. Actually, Nimit, I'm suffering from fever from since last 2 days, so I'm at home right now.
Okay, sir. No worries. No worries.
But yes, Shakti sir will be there in the cabin. So next lecture of your BDM will be conducted by Shakti sir, and they will be there in the campus. He will be there. And to meet Shakti
Okay,
sir, you
sir.
can go to location MB256.
Yes. Thank you, sir.
Yes. So Shakti sir will be there in the campus, and you can meet him and in MB256 cabin number.
Okay, sir. Sorry to disturb in middle.
No issue, not at all. Okay, so let's move further. Yes, so we were discussing this cluster analysis, outlier analysis. Yes, so mails which are having unusual content, they can be filtered as outliers. So you can say that the mails which are not having any kind of normal words, normal content, they will be having, or they will be considered as outlier or out. And to analyze all these things, that which kind of okay, initially what was happening in promotional mails was also considered as outliers. Normally they have identified that okay, this kind of mails are also sometimes useful, which are having promotions, which are having some schemes, some kind of offers. So what they have done, they have also considered, or they have also created a kind of different class, different group. That is, you are having nowadays kind of label as promotion mail or promotional mail. So your mails which are containing that kind of content, that will be considered, or are directly sent to promotions label. Right? So that is outlier analysis. The data that do not comply with general behavior or model, they will be considered as outliers. And outliers are usually discarded as a noise or exception. So generally what will happen, let us say you are doing some analysis, and for you, only the data points which are there within the cluster are important. So what you can do, in case, you can simply discard these outliers, but sometimes they are useful. Sometimes you want to identify, let us say, some kind of a new pattern, some kind of new things, or maybe possible that sometimes this kind of data points are creating new cluster. Right? So that is also important sometimes. That is nothing but evolution analysis. Here, outlier analysis is useful in spam mails, then irregular unknown numbers, the phone numbers from which you are getting the marketing calls, and that is also kind of unusual pattern. So what will happen, try to do this kind of thing, that pick up any random 20 to 50, 25 numbers from different states, start calling them, and you will be getting directly a kind of message that this number cannot be used for telemarketing purpose. If you do so, then your number will be stopped or blocked. So how they're detecting, how this kind of telecommunication companies are detecting all this kind of thing based on or irregular behavior or unknown behavior. Normally, you are calling at particular state only. Either you are calling within your hometown or some particular specific state, some specific city. But if you started calling in different multiple countries suddenly, then they are identifying all this your irregular or unknown behavior, and they are saying, or they are going to send this kind of notification or message, SMS, that you are using this number for telemarketing purpose. Stop it, otherwise your number will be blocked. So that is a kind of irregular or unknown behavior. Now, evolution analysis, as we have discussed, that sometimes this outliers are also creating a kind of new cluster, because they are coming up with new behavior, coming up with new kind of characteristics, and that is evolution. And gradually, this outlier may be possible. Gradually, they are forming a new group. That is kind of evolution, and that is evolution analysis. Now here, this evolution analysis is describing and modeling regularities or trends for objects whose behavior changes over time. Generally, sometimes what will happen, the behavior of different kind of outliers will change, or sometimes may be possible that the data points from the same cluster will change its values, will change its behavior. Update will be there. So what will happen, sometimes data points from the cluster will be shifted from other cluster, or the outliers are also forming kind of new group, new cluster. So that is a kind of evolution analysis, which kind of updates you are having, which kind of different behaviors you are having over time. Fine. So example given here is identify the stock evolution regularities for or all stocks and for the stocks of particular companies. So whenever any kind of sudden changes are there in any kind of company, for example, share market example is given here. So gradually, what will have what is happening in share market, that some companies are gradually increasing its values, some companies are gradually decreasing its values. Right? So here some evolution may be possible, that some evolution is going on due to some kind of inner changes in the company, or different kind of there are different strategies or the policies they are changing, due to which gradually they are increasing by some certain kind of values, by some minor points. So maybe possible that some kind of evolution is going on within the company, either in positive way or in negative way. But this kind of thing you can identify with evolution analysis. Okay, now next point, next topic is classification of data mining systems. This is one of the most easiest point. So based on the thing in which you are using your data mining system, or based on the technology that you're going to adapt in data mining, you're going to classify data mining systems. For example, which database technology you are using, which kind of statistics you are using, which kind of machine learning, or either you are using your data mining techniques in machine learning or not. You are using your data mining different disciplines for visualization purpose also, which visualization technique you are using, information science. Based on all these kind of things, you can classify your data mining system. Same topic, for example, database. If you consider the database, then which database you are using, whether you are using relational databases, data warehouse, transitional database, multimedia database, www web database, or what. So based on that, you can classify your data mining systems. Next is knowledge. Which kind of knowledge you are mining, which kind of knowledge you are seeking. whether you're going to perform classification or association or characterization, what. So based on the knowledge that you want to mine, based on that also you can classify your data mining system. Next is which technique you're utilizing, whether you are using techniques based on database or data warehouse or machine learning or statistics or visualization or other. So based on the technique that you are using, based on that also you can classify your data mining system. And the last is applications adapted, in which application you are adapting data mining, whether it is retail industry, whether it is telecommunication industry, whether it is banking, fraud detection, fraud analysis, stock market, text mining. Based on the applications in which you are adapting data mining, based on that also you can classify your data mining system. And this is also one of the most important and easiest topic from this unit, that is classification of data mining system. Okay, now the data mining system architecture, that is also important, and that is easiest one because we have already discussed some of the parts, or you can correlate this data mining system architecture with your KDD process. So try to remember each phase in sequence also, and try to remember this diagram also. So as we have discussed this KDD process here, you can correlate this KDD process with your data mining system architecture. And so here you are having database, data warehouse, www, and other repositories where you can store your data. So these are the things where you can store the data. Then what you're going to do? You're going to perform data cleaning, then integration and selection, and then you're going to store it in database or data warehouse server. Fine. So up to this, there is kind of common sequence that from the place where you're going to store your data, you're going to perform data cleaning, integration, and selection, and that cleaned, integrated, and selected data will be stored within database or data warehouse server. Fine. So the data that you're going to fetch, or the let us say you want to do some kind of analysis, or you want to get some kind of result. For that, the data will be fetched from here, database or data warehouse server. Now, from where the data is coming at this level, at this phase, data is coming from this different kind of sources, and the data that will be there, that will be available here, that will be cleaned, integrated, and selected. Fine. So the analysis that you will get, the result that you will get, that will be noise free, that will be only relevant or related to your analysis. So what will happen? Let us say you want to find some pattern, you want to do some analysis. Fine. So initially what you're going to do, you are simply going to write some query. You're going to fire the query using some tool, using some user interface. Fine. So here, this is the example, or this path you're going to follow. So you are writing down the query. You are going to use user interface. Then that query will be passed to this pattern evolution, which kind of pattern you want to mine. Then it will go to that data mining engine. So which kind of techniques, data mining techniques you're going to apply. And then the data will be fetched from this database or data warehouse server. And as per the requirement, you will fetch the data from this phase, and it will give you the return analysis in this sequence. So based on the query, on the data that you have mentioned, on the portion of data that you have mentioned in the query, it will perform this data mining technique. It will generate pattern, and in your user interface, it will provide you the kind of graph, charts, analysis as a result. Fine. So initially you are firing a query, and in return you're getting some kind of analysis, some kind of result. Fine. So user interface is just to it is kind of intermediate between the user and the data mining system. Pattern evolution, here you are having engine, or you can say the pattern evolution in which you're going to identify that which patterns are interesting and which patterns are not. Data mining engine in which you are going to apply various data mining techniques. Now what will happen? Let us say you are generating some kind of thousands of patterns. So while generating this kind of thousands of patterns, you can also store useful patterns in knowledge base. So in future, whenever required, you can also use those patterns that you have already identified, that you already mined. And so maybe possible that in future you can, or those patterns can be useful. So that in future, if required, you can also use that kind of knowledge in your data mining engine phase also. Now the same funda, same points are discussed here. A database, data warehouse, they are data store to store the data. Then database, data warehouse servers, they are going to use for fetching and combining the data. Then your knowledge base, that is this one. That is for turn data into meaningful groups according to the domain knowledge. So according to the domain, they are going to separately store the mined pattern or the knowledge that you have already mined, that you already identified. Then mining engine, that is to perform data mining techniques on data. Then pattern evaluation module, that is for finding out interesting patterns based on some measures. The measures already we have discussed, objective and subjective. And the last one is user interface to interact with user. Your mining system is going to interact with user using this user interface. And that is your data mining system architecture. Okay, the last topic is current trends and potential applications. So here you are having different kind of trends, different kind of applications of data mining, which kind of trends are there, which kind of applications are there of data mining, and that is discussed here in this topic. So here you are having, let us say, data analysis and decision support. Under this, you are having market analysis and management, risk analysis and management, and fraud detection and detection of unusual patterns. So based on this data analysis and decision support, you are having this kind of applications or this kind of trends. So in market analysis, what will be there? Target marketing. For which product you're going to target. Then CRM softwares, market basket analysis, cross-selling, market segmentation, all these kind of things are there under market analysis and management. These are the applications and trends of data mining. Then risk analysis and management, in which you are having forecasting, weather forecasting, for example, or forecasting of stock market values. Then customer retention ratio, whether how you can retain your customers. If customers are shifting from, let us say, Flipkart to Amazon, and you want to hold them back, how you can do that? How you can maintain your customer retention ratio? Then quality control. Then competitive analysis, when there is a kind of competition among companies, which kind of things they should do, which kind of things that they should observe, they should focus on. So these are the things under this risk analysis and management. These are the kind of potential areas, current potential trends, applications of data mining. And the next under this is fraud detection and detection of unusual patterns. That is outlier analysis that already discussed, that spam mails, telemarketing calls, all these things are there under fraud detection and detection of unusual patterns. And other applications are text mining, that is regarding email, various kind of documents. Now, yes, regarding documents, whenever you're going to prepare your project report, at that time you are going to generate one kind of report, that how much original your project report is, whether it is copied from other resource or that is your original words. The original words are used. And so this kind of documents you are also going to find out. So that is the kind of example of text mining. And so at the end you are going to generate kind of report, and in which you will be having that, okay, 5% of your report is copied from other source, or let us say 20% of the report, project report, is copied from other source. So this is the text mining. Web mining, you have already learning it as a subject. Stream data mining, the live data, audio or video or some kind of kind of let us say nowadays stock market, that is stream data mining, how you can deal with live data. Then bioinformatics, that is regarding, and bio data analysis, that is regarding that how the various medicines are working on let us say human, which kind of effects they are having whenever you are introducing some kind of new medicine or new vaccines, uh, whether or which kind of changes it will have, which kind of impact it will have, which kind of compounds that should add, which kind of compounds that should remove. That is regarding bioinformatics and biodata analysis. That is regarding all the fields. Let's say if you want to introduce kind of new uh, fertilizer, then which that fertilizer will be having which kind of effects on the crops. All these things are what? All these things are under bioinformatics and biodata analysis. Now, in market analysis and management, examples are given here that where does the data come from? That is whether you are collecting the data from credit card, debit card transactions, loyalty cards, discount coupons. So, for example, nowadays Reliance Trends or Reliance Trends is having some kind of offers. They are offering coupons, and they're trying to attract the customers. Now, where this data is coming from, that is whenever it is coming from, let us say offers by credit card, offers by coupons, by some kind of loyalty cards, or what. Fine. So this kind of analysis you can do. And next is target marketing. You are focusing or targeting on specific group, specific pattern, that is determine the customer purchasing pattern over time. For example, customers who are between 20 to 29-year old and with income 20,000 to 29,000 usually buy this kind of mobile phones. So you are targeting a kind of specific group of customers. And so some products are there which are focused for specific group of people only. Right? So you will try to target those kind of people. For example, they are offering some kind of credit card offer. If you are having this much income and if your age is between this, then you will be offered that kind of credit cards and you will get XYZ benefits. Same way, this kind of offers, this kind of target marketing is applied to retail industry and other industries also. For example, mobile phones, Flipkart, then other mobile phone manufacturer companies are also offering this kind of things, targeting various peoples, or how they are identifying that mobile phone should be of which range mobile phone should be introduced in India, which range mobile phone should be introduced in other countries, based on all these kind of things. What is the average age of people and what is their average income? All these kind of things are considered. That is nothing but the target marketing. And cross marketing analysis. Here you are trying to observe entities from different fields. For example, customer who buy computer A usually buys software. So computer and software, what is the relation? Computer is a kind of electronics product and software is totally from different field. So uh, is there any kind of relevance between these two different products? If yes, then how they are related? Positively related or negatively related? So that is kind of cross market analysis. The products from different fields, are they having any kind of relevance? If yes, then start offering some kind of discount, start offering some kind of offers. Right? So that is possible by finding out associations and correlations between these kind of products. Right? So based on these associations and correlations, you can identify that whether they are related or not. They are independent or related. If related, then positively related or negatively related. But sometimes possible that whenever customer is purchasing A, they are not purchasing B. Right? So if such kind of things are there, then you can say that they are independent. Right? So this kind of things you can identify using this kind of association and correlations. Right? So that's about market analysis and management. Okay, one more, some few more examples are there, but that we'll discuss in the next session. So let us keep up to this only. Okay, up to this, anybody any doubt?
No, sir.
Okay, thank you, Anjali, for the response. Jairaj Singh, Nimit, Brinda. Great. Fine. So let me take the attendance now. Just a minute. 2, 3, 4, 5. Great. Fine. Thank you so much, all of you. Have a nice day. Thank you. Thank you so much, all of you. Have a nice day.